Hello class, this is Ms. Friggins again at Starbucks filming a video on Unit 10, which is polynomials, Day 3, which are finding real zeros. In last video we talked about how the zeros are the x-intercepts of the polynomial, and if the polynomial function is written in factored form, it's easy to identify the zeros. But here we have a polynomial that is not written in factored form. And if you don't want to take the time to use your algebra skills to factor it, to be able to find the zeros, because sometimes factoring won't always give you positive results, then there's another surefire way to find the real zeros of the function. But it does involve a lot of calculations and a lot of computations. And so we're going to begin. So here we have a function, and we're trying to figure out what are the rational zeros. And there is this theorem in your notes called the rational zero theorem for rational numbers, for polynomial functions, which said to find the zeros of a polynomial function, there are possibilities that you can eliminate from P and Q and dividing P and Q. So what is P? Well, in this case, P is the last coefficient, which is A0, and Q is the first coefficient, which in this case, for this example, is 8. And so what the rational zero theorem says, if there is a factor of this polynomial, it is a result of dividing a factor of P by a factor of Q. In other words, P divided by Q could be a possible factor of the polynomial, a possible root of the polynomial. So let's take a look. In our example, P is 3 and Q is 8. So we have to also include positive and negative numbers. So first we have to identify the factors of P and identify the factors of Q, or the factors of 3 and the factors of 8. Well, the factors of 3 are 1, 2, and 3, and the factors of 8 are 1, 2, 4, and 8. In other words, these numbers are completely divisible by 3, and these numbers down here are completely divisible by 8. So in order to come up with possible real zeros, all we have to do is go through and list all the possible combinations of a number that has any of these numbers in the numerator and any of these numbers in the denominator. So the way that I list those is basically a nice and ordered way. I say 1 divided by 1. I start with one of the numbers in the numerator and then divide it by each number in the denominator. So what we have here is 1 over 1, 1 over 2, 1 over 4, and 1 over 8. So in that case, these are all the possible potential zeros of the polynomial. Now that they're all worked, they're just numbers I can try. And then I move down. I say, okay, now we look at 2 over 1, which is 2. And then I go look at 2 over 2. Well, that's 1. That's already in there. 2 over 4, well, that simplifies to 1/2. That's already in there. And 2 over 8 simplifies to 1/4. So that's already in there. And then I move down to the other factor in the numerator, and I get plus or minus 3. So plus or minus 3 leaves me with 3 over 1 is 3, 3 over 2 is 3/2, 3 over 4 is 3/4, and 3 over 8 is 3/8. So all that means is that these are all the potential zeros of this polynomial. So now that we have identified our potential zeros, now that all we have to do to figure out our answer is to test each and every single one of them to see if they are truly a zero. Now I know you're saying that's a lot of numbers to test, and unfortunately you're absolutely right, it is. I will show you 3 ways that you can test without a calculator, and then in class we're going to look at a much simpler way to test all of them with a handheld calculator, which will be so much quicker. But one of the ways that you can test is by picking one of the potential zeros and doing polynomial division. So let's say I pick in +1. Well, that means the factor would be x minus 1 because positive 1 minus 1 is 0. So my potential 0 is positive 1. And I can test to see if x minus 1 really does divide the polynomial and get me a remainder of 0. And in this case, it does. So for those of you who don't remember polynomial division, we take this and we say, okay, x, well, I need to divide that, multiply that by 8x cubed, so that means I'm going to try an 8x squared. Well, 8x squared times x is 8x cubed minus 8x squared, and so on and so on. So for those of you who remember this method, this is one method that could potentially work. But knowing you guys, you probably don't want to do something as tedious like this. So then we're going to move on to another method, which will always guarantee you an answer and might not be as difficult to determine. And that method is, I like to call substitution. Let me see if really 1 is really a factor, a 0. So how do I see that? Well, I plug 1 into the original function. When x is 1, what do I get out? And if 1 is really a 0, then f of 1 would give me 0. And in this case, f of 1 is 0, so 1 is a factor. 1 is a 0 of the polynomial. Let's see. Well, let me try. You got to be careful with that. So now, just because 1 works, it's not necessarily a given that the negative of 1 will work. So let's try. Let me plug in negative 1 into the function. When I plug negative 1 into f, I get out negative 14. So that tells me that negative 1 is definitely not a root, because if it was a root or a 0, I would actually get 0, and I don't. So that means negative 1 does not work. So then I just work my way down the line, plugging in different values and seeing what I get. So let's try another 0. Let's try, instead of 1/2, let's try negative 1/2. So we plug in negative 1/2 into the equation and I get out 0. So that means negative 1/2 is also a root. But is 1/2 that? You will have to plug 1/2 in to see. And I just work my way down until I find all the possible values. Now I told you it would be tedious, and that it is. Plugging in all these different values lets me know which are really roots and which are really not roots, or which are really zeros and which are not zeros. Because I want an end game for it to be a 0, and if it's not a 0, then it's not a root. So you have to test not only all the positive numbers, but all the negative numbers. That is a lot, but that's why you're in pre-cal. The last method we're going to look at to be able to figure out whether or not you have a potential 0 is actually a 0 is by synthetic division, which you may remember from from Algebra 2. Okay, so we're back, and I said I was going to show you one more method using something from Algebra 2, which is synthetic division, which you may or may not have gotten into, but you should have gotten into it, and it's very similar to what we've done before. So if you remember, the first row you write down are the coefficients of your matrix, of your polynomial, sorry. Coefficients of your polynomial, 8, negative 10, negative 1, and 3. 8, negative 10, negative 1, and 3. And then in blue is the number that we're testing to see if 1 is really a 0, which we know from previous that it actually is for this polynomial. The first thing you do is you bring down the 8. And when you bring down the 8, then that's what you're going to use to the potential 0 to multiply. 1 times 8 is 8. And then you're going to add negative 10 plus 8 is negative 2. And then you're going to multiply again. 1, but this time times negative 2. And that ends up being negative 2. So negative 1 plus negative 2 is negative 3. And then 1 times negative 3 is negative 3. And 3 plus negative 3 is 0. So yes, it works. We can apply the same method for another test. So here we have another 0, which is potential 0, which is 2. And of course, our coefficients 8, -10, -1, and 3, and we're going to test it as well. Bring down the 8. Oops, bring down the 8. So now we have 2 times 8 is 16. -10 plus 16 is 6. 2 times 6 is going to be 12. And then -1 plus 12 is 11. And then 2 times 11 is 22. And 3 plus 22 is 25. That tells you, since it's not 0, that this cannot be a 0 of our polynomial. So there you have it, 3 different ways to find real zeros. There are other ways that you can be smart about choosing which to test and which not to test, but those ways come with time and practice, which we'll be doing in class. All right, until next time.